Hi guys, I wanted to come on and make a quick video just re-explaining the information that you're going over this week, where you're using the Pythagorean theorem to find the distance between 2 points on a coordinate plane. So I've chosen 2 problems from the list of practice problems that I've provided on Google Classroom, and I just want to walk through the steps with you. This is problem number 1 from your classwork. The directions say, using the Pythagorean theorem, find the distance between each pair of points. So for number 1, we have a line segment, and for its endpoints, the first endpoint we have is at -2, +5, and the second endpoint is at -3, -5. So you've been given this line segment, and your job is to find the length of this segment using the Pythagorean theorem. Well, we know that the Pythagorean theorem only works with right triangles, and that's the information here at the top. When you have a right triangle, well, we know a triangle has 3 sides. When we have a right triangle, the side that's opposite the right angle, or the longest side, we know that's called the hypotenuse. The other 2 sides are called legs. In the Pythagorean theorem, a squared plus b squared equals c squared, our hypotenuse is always the longest side, and the hypotenuse squared is equal to the sum of the 2 legs squared, and your legs are represented by a and b. And you see I have a/b here and a/b here because those are interchangeable. So either one of the legs can represent your a or b, but the hypotenuse, the longest side, must be represented by c. So let's get into the problem. So looking at problem number 1, the first thing we need to do is create our triangle, our right triangle. Well, we see this segment right here that we've been given. If we draw a vertical line or construct a vertical line here, then construct a horizontal line here, that will create our right triangle for us. So I paused the video for a moment just to go ahead and construct the right triangle. And now that we have our right triangle here, we see that opposite the right triangle, the side that we're looking for is actually our hypotenuse. So we know that that side is going to be our C. It doesn't matter whether you allow this side or this side to represent A or B, because again, like I told you, those are your legs. So I can let A go here or B, and then the opposite value go here. Well, with the vertical and the horizontal line, you can just count the units. However, with the slant line, you won't be able to do that, so that's where the Pythagorean theorem will come in. So from this endpoint of this segment for side A to this endpoint, we're going to count our units, but I only count when I move. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So side A is 10 units. The same thing for B. From one endpoint to the next, it doesn't matter which one you start with. You only count when you move. That's 1 unit. So the length of side B is 1 unit. And in order to use the Pythagorean theorem, I only need to know 2 sides of the right triangle, and the Pythagorean theorem allows me to find the 3rd side. So I'm going to take the information that I have, knowing that I've been given both legs, one with the length of 10, the other with the length of 1, and I'm going to plug that into the Pythagorean theorem to find out the length of the hypotenuse, which is also the segment that I've been given to find. So my Pythagorean theorem is written out as a squared plus b squared equals c squared. We know that a is 10 units, and we're going to square it. Our b is 1 unit, and it's squared. And we're going to use this information to find our c, or our hypotenuse. So going to the calculator, I have 10 squared plus 1 squared, which equals 101. And that is equal to c squared. But I don't want to find c squared, I just want to find c. So to get rid of this squared, I'll do the opposite, which is take the square root of both sides. Because this is an equation, whatever you do to one side, you have to do to the other side. The square root of c squared will give us c. And then I'll go to the calculator to find the square root of 101. So in my calculator, I'm taking the square root of 101, and that gives me a number that I'm going to round. So this is an approximation of 10 units. Okay, so that's number 1. I'm going to choose one other problem from your classwork, and I'll use the bottom section from your practice problems and choose a problem with the same concept but set up a little differently. Instead of giving you the line segment, this particular problem that I'm choosing is going to give you just the ordered pairs. I've chosen to work problem number 13. The directions say plot the points on a piece of graph paper, then find the distance between each pair of points using the Pythagorean theorem. So I'm going to take each of the points that I've been given, 7, -3, and then I'm going to take 4, 3, plot each of those points, and connect the points. Then I'm going to follow through the same steps that were worked out for problem number 1. So using my graph paper, I'll go to +7, -3. So from the origin, I'll move to the right, +7, and go down 1, 2, 3 units, and that gives me the point 7, -3. My second point, or ordered pair, is 4, 3. So from the origin, because the 4 is positive, I'll go to the right, and then I'll go up 3 because the 3 is positive as well. And that gives me the location of my second ordered pair. So now I'm just going to connect the dots. Same process as before. I'm going to make a vertical line going straight down, then a horizontal line connecting the other endpoint. And what we've done, guys, is created another right triangle where I am looking for the hypotenuse, which is C, and allowing either of the legs to be A or B because they're interchangeable. Following through the same process, segment A, I can count from one endpoint to the next because that line is horizontal. 1, 2, 3, so A is equal to 3 units. And then for B, only counting when I move, 1, 2, 3, 4, 5, 6. So B is equal to 6 units. So the hypotenuse, that is my unknown. So taking the information, going to my paper to work the problem out. So my formula, a squared plus b squared is equal to c squared. A is 3 and it's squared. My b is 6 and it's squared. And again, I have to find the hypotenuse. Well, going to my calculator, we'll take 3 squared plus 6 squared and that gives us 45. But remember, we're not looking for c squared, we're looking for c. So we'll take the square root of both sides. And when we do that, going back to the calculator, finding the square root of 45. And that gives us approximately 6 7/10. So our hypotenuse, the length of that segment that we were looking for, is 6 7/10. So 2 problems, same exact concept. One, you were given the original segment. You created the triangle to find the missing side. For the second one, you were just given the ordered pairs. You had to plot them and create the right triangle and find the sides that are missing. Make sure you try a few of the practice problems. Remember, they are just practice. They do not have to be submitted to me. I've also provided the answer key there for you to check to make sure you're working these correctly. Additionally, we will have a help session on tomorrow from 2:45 to 3:15. If you could join in, if you have any questions, I'll answer them there regarding the classwork or the practice problems. If you have questions prior to that time, you can always send me a message through Remind or through Google Classroom. Remember to stay safe and hope to see you soon.